Differentiation by chain rule is the method we want to consider. So what we do is we let u be equals to x squared plus 2x plus 1. And therefore my equation changes to y raised to power 6. And now looking at that equation, I would not be able to look for dy dx. I would literally be looking for dy du. So for me to be able to look for dy dx, which is the first derivative of y with respect to x, I'll try to find the dy du, and then I look for the du, the dx. Now, if I differentiate dy with respect to u, I'll get 6 u raised to power 5. And then if I differentiate u with respect to x, I get 2x plus 2. And so that is what we call the chain rule. It makes it simpler for you to differentiate such equations. And therefore, my final solution becomes 6, 2x plus 2. And then we put back the u that we add. And remember, u is x squared plus 2x plus 5. U is x squared plus 2x plus 1 raised to power 5. And that gives me the first derivative of y with respect to x. I can then I let u is equals to 2x plus 1. Therefore, my equation becomes y is equals to sine u. Why do we do this? To simplify the part of sine. Now it's only u. So if I'm going to try and differentiate, so I'll get dy with respect to u, and then u with respect to x. That's it. So dy du, the derivative of sine x is cos. So it will be the cos of u for the first part, and the second part will be 2. So the first derivative, which is dy dx, the y prime, will be equals to 2 cos of 2x plus 1. And so what I do is I let u be equals to cos x, therefore y becomes e raised to power u. And again, therefore dy dx is dy du, because now y is related to u, times then du over du dx, because u is related to x. So, and that's the method we call the chain rule method. So if I differentiate the cosine, what do I get? First of all, dy du is e raised to power u, and then the du dx is negative sine x. So the first derivative will be negative sine x e raised to power u, and remember our u is cos x. Now the same problem, we could have solved it. We could have decided to differentiate it without employing the use of the chain. And for those of us, we could have taken this, you differentiate it, and that will give us negative sine x. And therefore, you could have said that the first derivative will be equals to negative sine x, then e raised to power the original function. And you can see those two solutions are exactly the same.